We have discussed practical harmonic analysis. So practical harmonic analysis we have discussed in the previous class and examples also, and today also. So we'll discuss few more examples on practical harmonic analysis. So next example here. So today's first example, the turning moment T on the crankshaft of a steam engine for the crank angle theta is given as follows. In place of x and y here, they have given theta and capital T. So theta in degrees, so 0, capital T, 30 degrees 2.7, 60 degrees 5.2, 90 degrees 7, and 120 degrees 8.1, 150 degrees 8.3, 180 degrees 7.9, 210 degrees 6.8, 240 degrees 5.5, 270 degrees 4.1, 300 degrees 2.6, and 330 degrees 1.2. So here theta is between what here? Started with 0 and ended with here 330. Started with 0, ended with 330. So full range Fourier series is 0 to 2 pi. Full range series Fourier series is 0 to 2 pi. So here theta is lies between 0 to less than 2 pi. Why less than 2 pi? Here 330 is there. So here starting point 0 and ending point what we have here 330, and it is less than 2 pi. So 2 pi means it is 360. 2 pi means 360. So we have 330. 330 as a ending point. So theta lies between 0 to 2 pi. Theta lies between what here? 0 to 2 pi. So theta is greater than equal to 0 and less than 2 pi. Because why greater than equal to 0? Why greater than equal to 0? Because theta starts with what here? 0 degrees and ends with 330 degrees. So 2 pi means what here? 360 degrees. So 330 is less than 360. So theta lies between 0 to 2 pi. So what is period T here? Period T is again 2 pi, because starting point is 0, ending point what we have here? 2 pi. So theta lies between 0 to 2 pi. So here interval is 0 to 2 pi, b minus a. So 2 minus 0 is 2 pi. So here interval is 0 to 2 pi. So period T is 2 pi. So we need to find here a0, a1, b1. We need to find here a0, a1, b1. And what is n here? N 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is 12. So according to this requirement, so we'll prepare the table. Now theta is what here? 0, 30, 60, 90, 120, 150, 180, 210, 240, 70, 100, 330. And here capital T values 0, 2.7, 5.2, 7, 8.1, 8.3, 7.9, 6.8, 5.5, 4.1, 2.6, 1.2. Now first cos theta, because we need to calculate here a0, a1, b1. So for a0, so what we have a0 as 2 by n summation of t, and a1 will be 2 by n summation of t cos theta, and b1 is 2 by n summation of t sin theta. Means we need summation of t and summation of t cos theta, summation of t sin theta we need. So summation of capital T, no problem. So add all the values of this capital T. So you'll get summation of T as 59.4. Now we want summation of T cos theta and summation of T sin theta. So for that, first calculate cos theta, right? So cos, in place of this theta, substitute these values. In place of theta, substitute these values. So first in this, so in place of theta 0, cos 0 is 1. In place of theta, substitute 30. So cos 30 is 0.866. In place of theta, substitute 60. 0.5. In place of theta, substitute 90, 0. In place of theta, substitute 120, minus 0.5. In place of theta, substitute 150, minus 0.866. In place of theta, substitute 180, so that is minus 1. In place of theta, substitute 210, minus 0.866. In place of theta, substitute 240, minus 0.5. In place of theta, substitute 270, 0. In place of theta, substitute 300, that is 0.5. And in place of theta, substitute 330. So I'll get 0.86, right? So we have a cos theta. So in place of theta, so go on substituting here 0, 30, 60, 90, so on. So first cos 0, 1, cos 30, 0.866, cos 60, 0.5, cos 90, 0, cos 120, minus 0.5, cos 150, minus 0.866, cos 180, minus 1, cos 210, minus 0.866, and cos 240, minus 0.5, cos 270, 0, cos 300, 0.5, cos 330, 0.866. Next we want here t cos theta, t cos theta. So multiply these two. So we have t values and we have cos theta values. So multiply these two. 0 into 1 is 0. T cos t. So these are t values and these are cos theta values. 0 into 1, that is 0. 2.7 into 0.866, 2.3382. 5.2 into 0.5, 2.6. 7 into 0, 0. 8.1 into minus 0.5, minus 4.05. 8.3 into minus 0.866, minus 7.1878. 7.9 into minus 1, minus 7.9. 6.8 into minus 0.866, minus 5.8888. 5.5 into minus 0.5, minus 2.75. 4.1 into 0, 0. 2.6 into 0.5, that is 1.3. 1.2 into 0.866, that is 1.0392. So add all the terms of this cos theta, we'll get summation of t cos theta, that is minus 20.4992. So this is summation of t cos theta. Next find here sine theta, right? So in theta, so sine theta, so wherever theta is there, no, go on replacing 0, 30, 60, 90, so on. So sine 0, 0, sine 30, 0.5, sine 60, 0.866, sine 90, 1, sine 120, 0.866, sine 150, 0.5, sine 180, 0, sine 210, minus 0.5, sine 240, minus 866, and sine 270, minus 1, sine 300, minus 0.866, and sine 330, minus 0.5. Now we want capital T sine theta. We want summation of T sine theta. So summation of T sine theta. So we want, so multiply this T and sine theta. So we have T values here and here sine theta values. 0 into 0 is 0. 2.7 into 0.5 is 1.35. 5.2 into 0.866 is 4.5032. 7 into 1 is 7. 8.1 into 0.866 is 7.0146. 8.3 into 0.5 is 415. 7.9 into 0 is 0. 6.8 into minus 0.5 is minus 3.4. And 5.5 into minus 0.866 is minus 3.4. 4.1 into 4.1 into this one. Minus 0.86 is 0.7 4.763. Next 4.1 into minus 1 is minus 4.1. 2.6 into minus 0.866 is minus 2.2516. 1.2 into minus 0.5 is minus 0.6. So add all the values of this t sine theta. So you'll get summation of t sine theta. So summation of t sine theta is 8.9032. Now calculate A naught. A naught is equal to 2 by capital N summation of t. So capital N is 12. So 2 by 12 and summation of t is 59.4. So 59.4. 2 ones are 2 six are. So 59.4 divided by 6 is 9.9. Now A naught is 9.9. We want A naught by 2 because constant term is A naught by 2. So 9.9 divided by 2 is 4.95. So this is A naught by 2. Now calculate A1. So A1 is 2 by capital N summation of t cos theta. So capital N is 16. 2 ones are 2 six are, and summation of t cos theta is minus 20.4922. 2 ones are 2 six are. So minus 20.4922 divided by 6 is minus 3.4165. So A1 is minus 3.4165. So calculate B1. So B1 is 2 divided by capital N summation of t sine theta, and N is 12. 2 1 and summation of capital T sine theta is 8.90. 8.9032. So 2 ones are 2 6 are. 8.90632 divided by 6 is 1.4839. So this is B1. So B1 is equal to 1.4839. So Fourier series up to first harmonic is given by t is equal to theta in place of x and y. So here theta and capital T is given. So A naught by 2 plus A1 cos theta plus B1 sin theta. So this is first harmonic, and A naught constant term. So capital T is equal to 4.95 plus A1 is minus 3.4125 cos theta plus B1 is 1.4839 sin theta. So capital T is equal to 4.95 plus into minus is minus 3.4125 cos theta plus 1.4839 sin theta. So this will be the required answer. Now move on to next example. Compute the constant term and the first two harmonics in the Fourier series of fx given by the following table. So first two harmonics means here first we need to calculate constant term a1, b1, a2, b2. We need to find here a0 by 2, a1, b1, a2, b2. So we need to calculate these 5 constants, right? Now given data is x values and y values are given. So x 0, 1.0, pi by 3, 1.4, 2 pi by 3, 1.9, pi to 1.7, and 4 pi by 3, 1.5, 5 pi by 3, and 2 pi 1.0. So observe the values here. Theta started with 0 and ended with what here? 2 pi. So what is the interval here? So interval x is lies between 0 to 2 pi. So 0 less than equal to x less than equal to 2 pi, because here x is greater than equal to 0. X is greater than equal to 0 because theta started with 0 and x is greater than equal to 2 pi. So ended with 2 pi. So started with 0, ended with 2 pi means it is a full what here full range Fourier series, right? So here x values, observe here, for 0 we have 1.0 and for 2 pi So we have here 1.0. So 0 and 2 pi. So we have y value as a 1.0 or 1. So here we need to take here this or this. We have to consider this value or this value. We have to consider here this value or this value. So 0 and 2 pi. So in these two, so we have to consider here this value or else this value, right? So here interval is 0 to 2 pi. That is 0 to the values of y at x equal to 0 and x equal to 2 pi must be same by the periodic property. So why it is same? By periodic property, because f of x plus 2 pi is equal to f of x. Because of this periodic property, so we have at x equal to 0 and at x equal to 2 pi we have y is equal to 1 because of periodic property. So we have these two values 0 and 2 pi. We have value of y as 1. So out of this means either we have to consider this one or this one. So in the given problem, the values of y at x equal to 0 and x equal to 2 pi both are same. So we must omit one and we have to consider this or this. We have to consider here this or this. So I will consider this one and I will omit this one, right? I will leave this one. I will consider this one, right? Now, according to this, you prepare the table. Now, the values of x are 0 and pi by 3 means 60 degrees, 2 pi by 3 means 120 and pi means 180, 4 pi by 3 means here 240 and 5 pi by 3 means here 300 and n is we are leaving this. I am considering this and I am leaving this. So here out of these two values 0 and this 2 pi we need to consider one and we need to omit one value. So here I will consider 0 and this 1.0 and I will omit or I will leave this 2 pi and 1.0. So out of the means these two values we have to consider one. So I will consider this value and I will leave this value. So n is equal to what here? 1, 2, 3, 4, 5, 6 because I am leaving this. I am leaving this 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I am leaving this, right? Now we have capital N is equal to 6. And what is A naught? A naught is equal to 2 by N, capital N, summation of Y. And A1 is 2 by capital N, summation of Y cos X. And A2 is 2 by capital N, summation of Y cos 2X. And B1 is 2 by capital N, summation of Y sin X. And B2 is 2 by capital N, summation of Y sin 2X. So I want summation of Y cos X, summation of Y cos 2X, and summation of Y sin X, and summation of Y sin 2X. So here N is capital N is 6. Capital N is 6. The values of X are 0, 60, 120, 180, 240, 300 and n is 6 and n is 6. Now prepare the table here. X values 0, 60, 120, 180, 240, 300. So in terms of degrees and corresponding values 1, 1.4, 1.9, 1.7, 1.5, 1.2. So we want y summation of y cos x and summation of y cos 2x and summation of y sin x and summation of y sin 2x we want, right? So for that first y values are given. So first calculate here, find this cos x, right? So in place of x, go on substituting 0, 60, 120, 180, 240, 300. So cos 0, 1, cos 60, 0.5, cos 120 minus 0.5, cos 180 minus 1, and cos 240 minus 0.5, and cos 300 0.5. We want y cos x, so multiply these two because we know this y values and we know cos x values. So multiply these two, you will get cos y cos x. So 1 into 1, 1. 1.4 into 0.5, 0.7. 1.9 into minus 0.5, minus 0.95. 1.7 into minus 1, minus 1.7. 1.5 into minus 0.5, minus 0.75. 1.2 into 0.5, 0.6. So summation of y cos x is, so add all the values of y cos x, you will get summation of y cos x. So you will get here as minus 1.1. Similarly, first calculate cos 2x. So first calculate 2x. 2 into x values are here. 2 into 0 is 0. Cos 0 is 1. 2 into 60 is 120 and cos 120 is minus 1. Minus 0.5. 2 into 120 is 240. So cos 240 is minus 0.5. Now 2 into 180 is 360. So cos 360 is 1. Then 2 into 240 is 480. Cos 480 is minus 0.5. 2 into 300 is 600. So cos 600 is minus 0.5. So here we want summation of y cos 2x. So find summation of y cos 2x. So for that, so first y cos 2x values. So y values are here. Cos 2x values are here. 1 into 1, 1. 1.4 into minus 0.5, minus 0.7. 1.9 into minus 0.5, minus 0.95. 1.7 into 1, 1.7. 1.5 1.2 into minus 0.5 minus 0.6. So sum of all y cos 2x values here will get here as minus 0.3. Now first find sine x values. So sine 0, 0. Sine 60, 0.87. Sine 120, 0.87. Sine 180, 0. Sine 240, minus 0.87. And sine 300, minus 0.87. So y sine x is, y values are here and sine x values are here. 1 into 0, 0. 1.4 into 0.87, 1.218. 1.9 into 0.87, 1.653. 1.7 into 0 is 0. 1.5 into minus 0.85 is minus 1.305. 1.2 into minus 0.87 is minus 1.044. So sum of all y sine x values, so we'll get here as summation of y sine x as 0.522. Now find sine 2x. So 2x, 2 into 0 is 0, sine 0 is 0. 2 into 60 is 120, sine 120 is 0.87. 2 into 120 is 240, sine 240 is minus 0.87. 2 into 180 is 360, so sine 360 is 0. 2 into 240 is 480, so sine 480 is 0.87. 2 into 300 is 600, sine 600 is minus 0.87. So we have y values and sine 2x values. So y sine 2x values are 1 into 0, 0. 1.4 into 0.87, 1.218. 1.9 into minus 0.87, minus 1.653. So 1.7 into 0 is 0. 1.5 into 0.87 is 1.305. 1.2 into minus 0.87 is minus 1.044. So add all the values of this y sine 2x. So we'll get summation of y sine 2x as minus 0.1 minus 0.174. Now summation of y. So sum of all the values of this y will be is 8.7. Now calculate a naught. A naught is 2 by n. N is capital N is 6. So 2 by 6. A naught is summation of y is 8.7. So 2 ones are 2 threes are 8.7 divided by 3 is 2.9. So this is a naught. A naught by 2 is what 2.9 divided by 2. So that is 1.45. So a1 is 2 by 6 and summation of y cos x is minus 1.1. So 2 ones are 2 threes are minus 1.1 divided by 3 is minus 0.3667 or minus 0.37666 as a 7, approximately minus 0.37. Now A2 is 2 by capital N is 6 and summation of y cos 2x is minus 0.3. 2 ones are 2 threes are. So minus 0.3 divided by 3 is minus 0.1. So this is A2. Now find B1. So B1 is 2 by capital N. Capital N is 6 and summation of y sin x is 0.522. 2 ones are 2 threes are 0.522 divided by 3 is 0.174 and B2 is equal to 2 by capital N. Capital N is 6 and summation of y sin 2x is minus 0.174. 2 ones are 2 threes are minus 0.174 divided by 3 is minus 0.58. So we have a naught by 2 and a1 a2 b1 b2 values. So substitute these two values in Fourier series. So we'll get here as y is equal to a naught by 2 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x plus so on, because we need up to only second harmonics. So substitute values. A naught by 2 is 1.45. A1 is minus 0.3666 cos x or approximately minus 0.37 cos x plus 0.174 sin x plus minus 1 cos 2x plus of this minus 0.058 2x. So this is required answer. And now move on to next example. Little bit different one. So far we have considered here the values in degrees, x values in degrees. So find the Fourier series to represent y of x up to second harmonic from the following data. So up to second harmonic means here again we need to find a naught by 2, a1 b1, a2 b2 we need to find, and values of x are here 30, 60 in terms of degrees, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, and values of y are here 2.34, 3.01, 3.68, 4.15, 3.69, 2.20, 0.83, 0.51, 0.88, 1.09, 1.19, 1.64. So observe here values of x. So starting point what here 30 and ending point here 360. So x lies between what here? X lies between x greater than 0 and less than equal to 2 pi. So again x lies between 0 to 2 pi. See here x greater than 0. So 30, see here 30 is greater than 0 and less than equal to 2 pi. 2 pi means here 360. So less than equal to. So last point, the last value is what here? 360. So x lies between 0 to 2 pi. So observe, this is very important. So x is greater than 0 and less than equal to 360 or it is 2 pi. So greater than 0 we have 30. So this is greater than 0 and we have here 360. So 360 is nothing but 2 pi. So x lies between 0 to 2 pi. So interval is 0 to 2 pi and period is 2 pi. So Fourier series up to second harmonics is given by y of x or f of x is equal to a naught by 2 plus a1 cos x plus b1 sin x plus a2 cos 2x plus b2 sin 2x. So we have a naught as 2 by capital N summation of y, and a1 is 2 by capital N summation of y cos x, and a2 is 2 by capital N summation of y cos 2x, and b1 is 2 by capital N summation of y sin x, and b2 is 2 by capital N summation of y sin 2x, and capital N. So what is capital N here? See here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So capital N is 12. So here I have not written. So capital N is what here? 12, right? Now we prepare the relevant table. So we want here y cos x, right? And y cos 2x and y sin x and y sin 2x and summation of this y. So we want. So we'll find one by one. So x values 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360. Corresponding values 2.34, 3.01, 3.68, 4.15, 3.69, 2.20, 0.83, 0.51, 0.88, 1.09, 1.19, 1.69. So summation, sum of all of this y, so summation of y is 25.21. So first we want cos x cos 2x, sin x sin 2x, then y cos x y cos 2x, y sin x y sin 2x. So first cos x, cos 30.87, 0.85, cos 90 0, cos 120 minus 0.5, cos 150 minus 0.87, cos 180 minus 1, cos 210 minus 0.87, cos 240 minus 0.5, cos 270 0, cos 300 0.5, cos 330 0.87, cos 360 1. So next cos 2x, so 2x, so 2 into 30, 60, cos 60, 0.5, cos 120 minus 0.5, cos 180 minus 1, cos 240 minus 0.5, cos 300 0.5. So cos 360 is 1, and cos 420, that is 0.5, cos 480 minus 0.5, cos 540 minus 1, cos 600 minus 0.5, cos 660 0.5, cos 720 is 1, because 2 into x, 2 into 360, that is 720. 2 into 330, that is 660 cos, right? 2 into 300, that is 600 cos 600. So we will get the values like this. Now we want y cos x. So y values are here and cos x values are here. So multiply 2.34, 0.87, 1.17, 3.10, 0.5, 1.505, 3.68, 0, that is 0, 4.15 minus 0.5 minus 2.075, 3.69 into 0.8 minus 0.87 minus 3.210. Similarly, minus 2.2 minus 0.7221 minus 0.255, 0, 0.545, 1.0353, 1.64. So add all the values of y cos x. So we'll get sum of this values as summation of y cos x is equal to minus 1.7013. Find summation of this y cos 2x. So first y cos 2x values. So cos 2x is 0.5, y is 2.34. So multiply these two, we'll get this as 1.17. Similarly, other values minus 1.505, minus 3.68, minus 2.075, 1.845, 2.2, 0.415, minus 0.255, minus 0.88, minus 0.545, minus plus 0.595, 1.64. So add all the values of y cos to x. So sum of these values as summation of y cos to x, this equal to minus 1.075. Now we want summation of y sin x and summation of y sin 2x. So for that, first sin x, sin 30.5, sin 60.87, sin 91, sin 120.87, sin 150.5, sin 0, sin 180, 0, sin 210, minus 0.5, sin 240 minus 0.87, sin 270 minus 1, sin 300 minus 0.87, and sin 330 minus 0.5, and sin 360 is 0. Now find sine 2x. So x values are 30, 2x, 2 means here 2 into 30, 2 into 60, 2 into 90, so on. So 2 into 30 is 60. So sine 60 is 0.87, sine 120 0.87, sine 180 0, sine 240 minus 0.87, sine 300 minus 0.87, sine 2 into 180 is 360, sine 360 0, sine 420.87, sine 480.87, and sine 600 0, and sine sine minus sine 330. So 2 into 330 is 660. Sine 660 is minus 0.87, and 2 into 360 is 720. So sine 720 is 0. Now multiply y and sine x. So we have y values and we have sine x values. 2.34 into 0.5 is 1.17. Similarly, we'll get values as 2.6187, 3.68, 3.6105, 1.845, 0, minus 1, minus 0.415, minus 0.4437, minus 0.88, minus 0.9483, minus 0.595, and 0. So add all the values. So summation of y sin x is 9.6422. Now similarly find y sin x, sin 2x values are here and y values are here. 2.34 into 0.87, that is 2.0358. Similarly other values, 2.6187, 0, minus 3.6105, minus 3.2103, 0, 0.7221, 0.4437, 0, minus 0.9483, minus 1.0353, and 0. So sum of all y sin 2x values is summation of y sin 2x, that equal to minus 2.9841. So calculate here. Not A1, B1, A2, B2. So one by one. So capital N is 12. So from the table, summation of this y is 25.21. Summation of y cos x is minus 1.7013. Summation of y cos 2x is minus 1.075, and summation of y sin x is 9.6422, and summation of y sin 2x is minus 2.9841. So calculate A naught. A naught is 2 by capital N, summation of y. 2 capital N is 12 and summation of y is 25.21. 2 ones are 2 six are 25.21 divided by 6. So this is equal to 4.2017. So this is A naught, and A naught by 2 is 4.2017 divided by 2. So that is approximately 2.1. right? Next, a1, so a1 is 2 by capital N into summation of y cos x. So summation of y cos x is minus 1.7013, and capital N is 6. 2 ones are 2 6 are minus 1.7013 divided by 6 is minus 0.28. Now calculate a2. So a2 is equal to 2 by capital N summation of y cos 2x. So summation of y cos 2x is minus 1.075. So 2 divided by capital N is 12 minus 1.075. 2 ones are 2 6 are minus 1.075 divided by 6. So this is minus minus 0.18. Now b1 is equal to 2 divided by capital N summation of y sine x. So summation of y sine x is 9.6422, and capital N is 12. 2 ones are 2 6 are 9.6422 divided by 6 is 1.61 approximately. Now B2 is equal to 2 by capital N is 12, and summation of y sine 2x is minus 2.9841. 2 ones are 2 6 are minus 2.9841 divided by 6 is approximately minus zero point 0.5. Now substitute this. So we have required Fourier series up to second harmonics, because we need up to second harmonics. So that is given by, so y of x is equal to a naught by 2, 2.1 plus a1 minus 0.28 cos x, b1 1.61 sin x. So this is first harmonic, and second harmonic is a2 minus 0.18 cos 2x plus b2 is minus 0.5 sin 2x. So this is required answer. Now today I'll stop here only, and tomorrow also, so we'll solve few more examples on this practical harmonic analysis. So tomorrow will be the last class for this module 2, right? So